All right, so today we're going to take a deep dive into a tech story. And, well, it's got twists and turns you wouldn't believe. I mean, we're talking about a little invention that started out in, of all things, copy machines. And now it's showing up in holographic data storage. And even optical tweezers. Seriously.
It's crazy, right? It's one of those inventions that's quietly revolutionized so many aspects of our lives. And most people probably have no idea it's even there.
Exactly. And our guide for this journey is an article called Digital Light Processing and Other Party Tricks, written by William L. Weaver. It was published all the way back in July 2002 for Scientific Computing and Instrumentation.
Right.
So buckle up, because we're going from everyday tech to the edge of science fiction, all thanks to something called the Digital Micromirror Device, or DMD.
Yeah, the DMD, it's essentially a grid of microscopic mirrors, each so small, it's dwarfed by a human hair. But here's the thing, each of these tiny mirrors can tilt back and forth thousands of times per second.
Thousands of times per second. That's mind-bogglingly fast.
It is. And that speed is precisely what makes DMDs so remarkable. It's this rapid controlled tilting that allows them to manipulate light and create images.
Okay, so it's like a choreographed dance of light, with each mirror reflecting light in a precise direction.
Precisely. And this dance of light is what's used to create the images you see on DLP TVs and projectors.
DLP, that's the technology behind those super bright, high-contrast projectors, right? The ones that seem to have a cleaner image than your average projector.
That's the one. DMDs are the heart of DLP technology because they're reflecting light directly. They create a much sharper, more vibrant image compared to, say, LCD projectors, which work by blocking light.
So we've gone from these incredibly tiny mirrors to a technology that's literally illuminating our world. Yeah. But the story doesn't stop at DLP, does it?
Not by a long shot. Remember those copy machines I mentioned? That's where DMDs really got their start, before DMDs. Creating a sharp copy from a digital image was a clunky process. You had to convert the digital information into a light pattern that would then expose the photosensitive drum.
I'm guessing those early conversions weren't very precise.
You got it. The result was copies that were often blurry or lacked detail. The DMD came in and changed the game entirely. Think of it as a gatekeeper for the light, precisely controlling which areas of the photosensitive drum get exposed and how much light they receive.
So the DMD was like a digital conductor orchestrating the light to create a perfect copy.
Exactly. And just as the invention of the transistor revolutionized electronics, the DMD did the same for light.
Hold on, that comparison to the transistor, that's huge. The transistor is basically the foundation of our entire digital world. You're saying the DMD, is that important for light?
Absolutely. The transistor allowed us to control the flow of electrons, leading to the microchips and integrated circuits that power our computers, smartphones, everything. The DMD, on the other hand, controls the flow of photons, the fundamental particles of light.
So the DMD is like the transistor's photonic cousin.
A perfect analogy. And just as the transistor led to an explosion of electronic innovation, the DMD is doing the same. For light-based technologies, we've talked about displays, but there's so much more.
Okay, you've got me hooked. Where else do these tiny mirrors take us?
Well, for starters, there's holographic data storage. It sounds like something straight out of Star Wars, but DMDs are making it a reality.
Holographic data storage. That's where you're storing data as 3D images instead of on a magnetic surface like a traditional hard drive, right?
Exactly, and the capacity is mind-blowing. Weaver's 2002 article talks about a company called In-Phase Technologies that was developing a system using DMDs to record and read these holographic images. Imagine a single disk holding 100 gigabytes of data. That's like fitting a whole library on something smaller than a DVD.
Well, it makes you wonder what kind of progress they've made in the past 2 decades. I mean, what are the storage capacities like now?
Well, it hasn't quite hit the mainstream yet, but the technology has advanced considerably. Researchers are working on making holographic data storage more practical and affordable, and the storage capacity keeps increasing. It could be a game changer, especially for fields like scientific research or archival storage, where massive amounts of data are involved.
So DMDs could be revolutionizing how we store information. But it sounds like that's not all they can do. Weaver also mentions something called optical tweezers. What in the world are those?
Optical tweezers use light to manipulate microscopic objects. Imagine using beams of light to trap and move individual cells.
Hold on, you're saying you can use light to pick up and move a single cell, like it's some kind of microscopic tractor beam.
It sounds like science fiction, I know, but it's a real and incredibly powerful technology. And DMDs play a crucial role. By shaping and controlling laser beams, they can create the precise optical forces needed to manipulate these tiny objects. Researchers are using optical tweezers for all sorts of amazing things, from sorting and moving cells for medical research to assembling tiny, intricate structures at the nanoscale.
It's like Conti having microscopic hands. That can build things atom by atom. It seems like something. That could revolutionize medicine and bioengineering.
Absolutely. And remember, that article was written in 2002. Imagine the progress they've made in over 20 years. It makes you wonder what the future holds for DMDs, what new and unexpected applications might emerge.
That's what I love about these deep dives. We start with something seemingly simple, and then it explodes in all these fascinating possibilities. What do you think the future holds for DMDs? Where are we headed next?
Well, we've talked about holographic data storage and those incredible optical tweezers. It feels like we're already living in the future. What else could these little DMDs possibly have in store for us? You know, it's funny. We've seen DMDs creating images, storing data, even manipulating microscopic objects.
It seems like from the everyday to the extraordinary, they can do it all.
Yeah. But what if? What if we could use DMDs to manipulate light itself, to shape and mold it in ways we haven't even imagined yet?
Okay, now you're really taking us down the rabbit hole. What do you mean by manipulating light itself?
Well, think about all the properties of light. Its wavelength, its intensity, its polarization. What if we could use DMDs to precisely control these properties on a very fine scale?
That's a fascinating idea. Where could that kind of control lead us?
Oh, the possibilities are endless. It could revolutionize fields like telecommunications. Imagine. Faster internet speeds, even more powerful fiber optic networks, all thanks to our newfound ability to manipulate light itself.
Okay, that's a future I can definitely get behind. Faster internet is always a good thing.
Right. And then consider the field of quantum computing, which relies on manipulating individual photons.
Quantum computing is one of those things that still feels like science fiction. But the potential is mind-blowing.
Absolutely. And DMDs, with their ability to control light at the single photon level, could be a key to unlocking the power of quantum computing.
It's amazing to think that these tiny mirrors
Yeah.
could be at the forefront of such a groundbreaking field. We're talking about technology that could revolutionize not just how we live and work, but also how we understand the very nature of the universe.
It's quite a journey, isn't it? From humble beginnings in copy machines to the potential to reshape the future of data storage, computing, and even our understanding of the cosmos.
It really is, and it's a testament to human ingenuity and the power of asking, what if? Just like William L. Weaver said back in 2002, like it's electrons controlling electrons' transistor cousin, the electrons controlling photons DMD continues to facilitate new innovations, inconceivable at its inception.
He really hit the nail on the head with that one. Who could have predicted all this? From a tiny chip with microscopic mirrors, it makes you wonder, what other incredible applications are just waiting to be discovered?
Well, I think it's safe to say that the future of DMDs is bright, and I, for one, can't wait to see what amazing innovations come next. Thanks for joining us on this deep dive into the world of digital micromirror devices. It's been a fascinating journey, and I hope you've enjoyed it as much as we have.
It's been a pleasure exploring this incredible technology with you. And remember, the world is full of fascinating discoveries, just waiting to be made. Keep asking questions, keep exploring, and you never know what amazing things you might uncover.
That's a great note to end on. Until next time, keep diving deep and keep those minds engaged.